In this video, we'll take a look at factoring trinomials with a leading coefficient of 1. We'll take a look at the slide. You'll see x squared plus bx plus c. This is the form of a trinomial. Suppose we want to factor x squared plus 5x plus 6. In order to do that, we have to ask ourselves the question, what two numbers can I multiply to get the last number in my trinomial, but add to get to the middle number in my trinomial? In order to do that, we can take a look at and practice the idea of coming up with the numbers that multiply but also add. So here I have what I call X boxes. These are little X box things. And what we're going to do is try and figure out what multiplies to get to the top number but adds to get to the bottom number. So if I'm looking at 4, I can list my factors of 4. 1 and 4, 2 times 2. Those are my combinations. Which one of those will add up to 4? 2 and 2. Multiply to get 4, but add to get 4 as well. For 12, I want to come up with all of my factors of 12. I've got 1 times 12, I've got 2 times 6, I've got 3 times 4. Which one of those combinations will add up to 7? 3 and 4 will work. There will only be one combination that works. All right, for the next one, I need my factors of 9, 1 times 9, and 3 times 3. Which two would add up to 6? Because we're going to multiply to get to 9, but add to get to 6. 3 and 3 will work. Go ahead and practice this idea on the next 6 X boxes. Remember, you want to multiply to get to the number on the top, but add to get to the number on the bottom. Pause the video and try. Take a look at your answers here and be very careful with the negatives. It's easy to come up with numbers that multiply to get to negative 24, but then figuring out which one should get the negative sign. So 3 times negative 8 multiplies to negative 24. It also adds to negative 5. So just be careful with that. Double check your negatives. If you can do this X box stuff, then you can factor a trinomial with the leading coefficient of 1. So we're going to go into this example here. It says x squared plus 3x plus 2. Here are our steps. Our first step is to draw 2 sets of parentheses, because when we factor a trinomial, we're going to get a binomial here. Our first two terms have to be x. Why would that be? Well, if I look at my first term here in my trinomial, it's x squared. How could I get x squared through multiplication? The only way to do that is by taking x and multiplying it by itself. So when I factor that, that's what goes here, little x's. Next, I want to think of what numbers multiply to get to the last term, but add to get to the middle term. The answer to that would be 2 and 1. 2 times 1 is 2. When I add 2 to 1, I get 3. So those little side numbers here go in to the second part of our parentheses. The 2 is positive, so I write down plus 2. The 1 is positive, I write down plus 1. And you're done. You've just factored your first trinomial. Always verify, which means take your answer here, take your factors, and go ahead and do your double distribution. And make sure you get the terms, the polynomial that you started with. So let's see if we can put that into play. Here's our example from the beginning, x squared plus 5x plus 6. Well, I'm going to draw my x box. I'm going to put 6 in the top because I need to multiply to get to 6, but I have to add to get to 5. I'm going to draw my 2 sets of parentheses. And I'm going to take the square root of x squared. That goes here. And now my job is to come up with the factors of 6. 1 and 6, 2 and 3. Which one of those will add up to 5? The answer is 2 and 3. They're both positive, so I need a plus 2, I need a plus 3. Now if you were to write the 3 first and then the 2, that's fine. X plus 3, x plus 2. That's exactly the same answer. The order of our parentheses does not matter, because in between is multiplication, and multiplication is commutative. Should you verify and check? Absolutely. X times x is x squared. X times 2 is 2x. 3 times x is 3x. And 3 times 2 is 6. Put together your middle terms, because they are like, and we'll get 5x plus 6. So again, your answer are the factors. This is just the check that you got it right. Let's try our next one. X squared minus 6x plus 8. Again, I need to multiply to get to 8, but I need to add up to get to negative 6. Draw my 2 sets of parentheses. Come up with my factors of 8. 1 and 8, 2 and 4. Now I need to come up with a combination where I'm going to get negative 6 when I add. Well, I think it's going to be 2 and 4. But I'm going to need to make them negative. Negative 2 times negative 4 will get us a positive 8. So my factors are x minus 2 and x minus 4. Double check that you're right by verifying. Go ahead and pause the video and try these last two. We have our answers of x minus 2 and x plus 1. And for the last one, x minus 3, x plus 5. Definitely verify that you've got that correct. We're going to put it all together now and take a look at solving these trinomials. We know that we need to put all the terms on one side and a 0 on the other. And then we factor. So we're going to go ahead and do that. Our first example, I have all of my terms on one side, 0 on the other, and it's a trinomial. So I'm going to go ahead and build my 2 sets of parentheses and maybe a little X box over here. I know my numbers need to multiply to 12, but add to 8. I think my answer might be 6 times 2 multiplies to 12, and 6 plus 2 adds to 8. So I'm going to go ahead and write that as my factor, x plus 6, x plus 2. In order to solve, we then use the product property rule, the 0 product property rule, and set our factors equal to 0. And we solve each of these little mini math problems. We'll get a solution of negative 6 as well as negative 2. Taking a look at example B here, my equation is not solved for 0. So that means I'm just going to subtract 18 on both sides. I'll rewrite my problem as x squared plus 3x minus 18 equals 0. I'll go ahead and start building my parentheses. And maybe over on the side here, I'll do a little X box. I'll put negative 18 in the top and 3 in the bottom. I need two numbers that multiply to negative 18 but add up to 3. I know it's going to be a combination of 6 times 3, but I need to figure out which one will give me the negative 18 but a positive 3 when I add. I think if I put my negative sign right there, 6 times negative 3 is negative 18, but when I add up 6 and negative 3, I get a positive 3. So therefore we have our answer, our factors I should say, as x plus 6 and x minus 3. We'll go ahead and set each of these factors equal to 0 and solve. We'll get our answer of x equals negative 6 and positive 3. Our last example here is the same, solve. It just asks me it in a different way. It says find the zeros of the function. Well, we know what that means. We just make this part f of x equal to 0 and then solve. So I'm going to set up my parentheses. I'm going to set up an X box over here, negative 20 on top, and a 1. Thinking of two numbers that multiply to 20, I know it's going to be 4 and 5, but what combination of negatives will I have till I add up to 1? I think this 4 needs to be negative. Negative 4 times 5 is negative 20. When I add it, I get 1. So I'm going to go ahead and put that into my factors and set each factor equal to 0 to solve. Get x equals 4 and x equals negative 5. You can write your answer that way, or you can write x equals 4, comma, negative 5. Either way, it's correct. All right, you go ahead and try these examples. Pause the video, work on your factoring of trinomials, work on your solving. Remember that finding the roots and finding the zeros is the same thing as solving. Set your equation equal to 0 and solve. All right, now that you've had a chance to complete these problems, go ahead and take a look. We factored for A, B, C, and D. For E, F, we found the roots, which means we set our equation equal to 0 and factored, and then set our factors equal to 0 and solved. G and H, we found the zeros of the function, which also means we set our equation equal to 0, we factor, and then we set our factors equal to 0 and solve. In our previous video, we learned about type 2 factoring, which is when we have a binomial. That is the difference of perfect squares. In this video, we took a look at type 3 factoring. You have a trinomial with a leading coefficient of 1 in the form of x squared plus bx plus c. We draw two sets of parentheses. The first term will be an x in both. And then we look for two numbers that multiply to get our c, our constant, but add up to get b, the coefficient of x. We multiply our factors to verify. Okay, check in next time for our next video on 4 terms that need to be factored.